Okay, so we're going to start off finding just the difference of squares, and then we're going to find the sum and difference of cubes. Okay, you're going to see in a little bit why we can't do the sum of squares, or we could, we're just going to choose not to, and I'll show you why not. Your homework, you're going to finish the other half of your page from yesterday, that is difference of squares, and then I gave you a worksheet today that's just the difference and sum of cubes. Okay, so the other half of last night, and then this new worksheet. It is Labor Day weekend, so you have all these days to get all this homework done, which is what you're going to do, right? So you will turn all that in, so that's technically 3 assignments. You'll give all those to me on Tuesday, if and when we return. We'll see what the hurricane does. Okay, so whenever we come back, you're going to give them to me. Deal? Beautiful. Okay. What? Someone have a question? Okay. All right, so we have 2 essential questions today. The first one is how can you factor a polynomial into the product of binomials? And then how can you factor the sum and difference of perfect cubes? Okay, so those are our 2 main topics today. Here we go. Let's look for patterns in factoring. These are our 2 things we're going to do. I've already said that. Here we go. So the first one we're going to do is difference of squares. So if I have a squared plus b squared, meaning it's only a binomial, right? It's missing that middle piece. Is going to be equal to a plus b times a minus b. Doesn't that kind of remind you of a vocab word we learned that starts with a C, with when we did like our I's and stuff? No, not complex. Close though, the complex conjugate. Yes, this is the conjugate, right? Same exact thing. One's plus, one's minus. Because remember, with our complex numbers, the reason we did that was to get rid of the middle term, right? To get rid of that I. So that's what's happening here also. We don't have a middle term. The first and last piece are both perfect squares. So we can rewrite it as the square root of each, 1 plus, 1 minus. Okay? People tend to really like these. And I think some of you looked at that paper yesterday and kind of caught on to what it was going to be. If it is adding, we call it prime. Okay? There is a way we could use the imaginary number and bring it back in, but we're not going to. We're going to keep it simple for this part. Okay? So from now, when you see, if you see a sum of squares, we're just going to call it prime and say you can't do it. All right? Here we go. So x squared minus 100. Number 1, is it a difference? What does difference mean? It means subtract, right? So is it subtracting? Yes, beautiful. Is it 2 perfect squares? Is x squared a perfect square? Yeah. Yes, x squared is a perfect square. Is 100 a perfect square? Yes. Yes. Okay? There is a difference of 2 perfect squares. So you essentially take the square root of each piece. There we go. So what is the square root of x squared? X. It is x. And what is the square root of 100? 10. There you go. And we do 1 plus, 1 minus, we're done. Yeah. Okay. Now, if it was x squared and then like 102, we couldn't do this because it's not a perfect square. They have to both be perfect squares. You good? Okay. All right. A little bit more happening here. We have 4x squared minus 81y squared. First thing to look for, is there a difference? Yes. So far, so good. Is 4x squared a perfect square? Meaning, could I square root this whole thing? Yes. But we can't do it yet. Is 81y squared also a perfect square? Yes, it is. Ooh. Bless you. I was sneezing this morning too. Something's in the air. Maybe we're allergic to hurricanes. That's what's in the air.
Definitely not.
Something. Okay, so because they're perfect squares and there's a difference, we can move forward. What is the square root of 4? 2. What is the square root of x squared? X. Okay. What is the square root of 81? 9. 9. What's the square root of y squared? Y. Y. Yep. 1 plus, 1 minus. Would it matter if I did minus and then plus? No. Order does not matter. When we're multiplying, 2 times 3 is 3 times 2. right? So since we're writing our answers as products, it doesn't matter which one you put first. We good? Still pretty simple? Told you like this one. Okay. And then some people, it'll be simple, and then they'll just go through it real quick, and they forget to check themselves. Like this one. Is there a difference? Yeah, we are subtracting. Do I have perfect squares? No. So some of you might jump ahead and say, oh, it's prime, I can't do it. It was only prime if there was a plus sign, right? Here, and I gave you a little hint in the corner, is there a GCF that we could take out?
Yeah.
Yes. What could I take out of both sides? 2. I could take out a 2. What else? An A can come out, and a B can come out of both, right? Do we see that?
Yep.
So when we take that out, so I divided that by 2, so it's gone. Divided that by A, that's gone, right? B cubed, I took one of the B's out, so I got B squared left right here. Other side, 50 divided by 2, is 25. A to the 5th divided by A to the 4th, B divided by B, it's gone. It's technically it's 1, it's not 0, but the whole piece did get moved to the front, so it's not written there anymore. Okay, so now let's see what happened. Is there still a difference? Yes. Is B squared a perfect square? Yes. Is 25 a perfect square?
Yes.
Is B to the 4th a perfect square? Yes. That's B, yes, sorry, A to the 4th. Yes, because that's A squared times A squared. Any even exponent is going to be a perfect square. Okay? You just divide it by 2. You split it up into 2 pieces. Okay? As long as we have an even exponent. So, we still have 2AB at the front. Doesn't go away. 1 plus, 1 minus. What is the square root of B squared? B. What is the square root of 25? 5. And what is the square root of A to the 4th? A squared. Good. And could you always check your answers? Yes. If you really wanted to, you could FOIL back through. Distribute and multiply. All right, I would like for you to try the next one. So 3x to the 5th minus 48x. And I did give you a little hint because I asked you to look for a GCF. Okay, so you look for that GCF and you try it. And I know you're not in tables, but you can definitely talk to someone in front of you, behind you, next to you. There's still more, you can still work with somebody if you want to. All right, so your GCF should have been 3x. So check with me. Your GCF should have been 3x. We're left with x to the 4th minus 16. Did we end up with a difference of squares? Yes, we did. Okay, let's think about it. So 3x is still out here. What is the square root of x to the 4th? X squared. You split it into 2 pieces. Okay, and what is the square root? Oops. What is the square root of 16? 4. Good. But wait. What if I told you this problem was not done? What if I did this? I ended up with another difference of perfect squares. X squared minus 4 is also a difference of squares. So, if this was a quiz or a test or something, you would not be wrong, you just wouldn't be done. If that makes sense. I'd probably take away like a point or 2 if you didn't complete the problem. Okay, so this one was a little tricky because it had a perfect square inside of a perfect square. But besides that last piece, did we do okay? Yeah? Yes, ma'am.
How would you write the final answer?
This right here, this last piece, that is our final answer.
Okay.
Yep. We okay? Ready to take it up a notch?
No. Yeah.
Well, we're going to. We're going to turn that dial. Mm-hmm. Okay, we are going to move on now to sum and difference of cubes. Now, what is nice about these is that there is a pattern that we can always follow, okay? And there's a little acronym to remember for SOAP. So on the side, you see the SOAP, okay? For S, it's, I feel like I should show it to you instead of say it out loud because it's going to be confusing. Hold on. I'll go back. Okay, so ignore this for right now. Look at this. This is SOAP. So it's how we set up our parentheses. We always set it up as A, same sign B. Okay? So S is for same sign. Then our next parentheses, we always go A squared, opposite sign, A times B. That's our O. Then it's always positive B squared. So that the word SOAP helps you figure out what signs go where. So S is same sign, O is opposite sign, and then AP is always positive. So that tells you the order of your signs every single time. Every single time. Okay? So same sign, opposite sign, always positive. Okay? We can do a sum of cubes and a difference of cubes. And if you're not familiar with your cubes, I would maybe start writing them down. Or, fun thing about calculators, you can raise things to the power of 3. Okay? But you should know 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. So hopefully we know to at least 5-ish. That's probably the numbers you've been working with the most. But again, you have calculators. You can always type things in and see. Okay? We good? Do we have the SOAP? I'm gonna go back a slide. So notice the pattern. So A cubed plus B cubed. Remember, S is same sign, right? So we have A plus B because it was plus to begin with. Then A squared, opposite sign of A times B. And then always positive B squared. Okay? And you'll always set it up with your binomial and your trinomial. Always, always. And yes, you're going to need to know these formulas. I cannot give them to you. I know, I'm sorry. Prepare for the worst. Maybe the best will happen. Maybe she'll let me give you.
Will always happen, like every year in September we have her.
Yeah, hurricanes they happen. Okay. Well, in Georgia, we always watch them happen. But Irma took away 3 days of school for us when I was up there.
As long as it takes away school, it's fine.
So, we did Cyber Days though, is what we did. So like we weren't at school, but they did school online and stuff. So they didn't have to make up the work later. They just did it that day. Some people they had time. But it was so we didn't have to go back and make up days. We called it a Cyber Day. So. Well, I feel like when y'all get hit by a hurricane, it's a little bit different than when Georgia gets hit by a hurricane. All right, here we go. So x cubed plus 2 cubed. The way it's written is there a sum? Yes. Here our sign doesn't matter. Are those 2 different cubes? Yes, I have x cubed and 2 cubed, okay? Now, my formula has A's and B's going on. Which one is my A? A is technically x, and B is technically 2, right? So, it is a sum of cubes. So, A cubed plus B cubed starts off with A plus B. It always starts off with the same sign. So, we're going to start off saying what plus what? X plus 2, okay? Now the next parenthesis. It always goes A squared, AB, B squared. Always, always, always. It's just our signs are going to be different each time, okay? So A squared is going to be X squared. According to SOAP, my next sign is opposite. So it's going to be minus. Okay? What is A times B? 2x, good. And then always positive, what is B squared? 4. Okay, so there is more to remember. Okay, so we're just gonna keep practicing it over and over and over again. But that SOAP, that word, will help you. Same, opposite, always positive. That's it. Yep, that's it.
Oh, this is a piece of cake.
That is it. Yep. No, I mean, GCFs will come into play in a little bit, but that's about as hard as it'll be. Okay, let's do another one. Let's do another one. So, r cubed minus 7 cubed. Are those two cubes? Yes. Is this difference or sum this time?
Different.
It is difference. So since it's difference, my first parentheses, will it be a plus b or a minus b? A minus b. Your first parentheses matches with what you were given. Okay. What is technically my a this time? A is r and b is just 7. Yeah, just 7.
Okay.
All right, so let's set it up. What's my first parentheses going to look like? What is it? R minus 7. Remember, SOAP, same sign. It matches with what you start with. Okay. Whoa.
So get to the bottom of this.
Okay. Calm down there, friend. Okay. Now, I need a squared. It's always going to go a squared, ab, b squared. So a squared is r squared. Yep. What is my next sign going to be? A plus. What's a times b?
7R.
Mm-hmm. And then what's my last sign?
Plus, positive.
Yep.
And it's 49. 49.
7 squared, which is 49. Again, this thing comes with practicing it and doing it over and over and over again. One more? Uno más? Well, I have like 4 more, but. Okay, this one's written a little bit differently. Do we agree? Yes. I have 8x cubed plus 125y cubed. Now, this sign doesn't tell me if I can or can't do it. What's up? Okay. Is 8 a perfect cube?
Yes.
Yes. Is x cubed a perfect cube?
Yes.
Yes, right, Sal? Is 125 a perfect cube?
Yes.
Is y cubed a perfect cube? Yes. Right, Tiger? Yes. I see you. All right? They are perfect cubes. So this time, what is A? Almost. It's something x. What's the cube root of 8? 2. It's 2x this time. Okay? And B is going to be 5y. Good. Is this a difference of cubes or a sum of cubes? It is the sum of cubes. That means my first sign is going to be a positive. Yes, it's going to be a positive. So it's going to be what plus what?
2x plus 5y.
Yes. All right. My next piece is what? Who can remember? I heard it, a squared. So 2x squared, I squared both of those. So 2 squared is 4, and x squared is x squared. So that's the same thing as saying 2x squared. That's our a squared. All right. Will my next sign be positive or negative? Negative. All right, what is a times b?
10.
Yes, good. Because that was 2x times 5x. That's our AB. Good. And then our last piece is always what sign?
Positive.
Always positive. And it's going to be b squared. So remember, we take 5y and we square both pieces. So that becomes what? 25y squared. So even though we had numbers and variables going on, when we square it, we just square both. We good? I want to do one more together before I let you do one by yourself. Bless you. Does that sound okay? One more together? Okay. The only reason why I want to do this one with you is because it's almost too easy, if that makes sense, and you'll see what I mean in a minute. Yes, sir. Stretching.
Yeah.
Do you have a question? Okay. I can never tell the difference. All right. 5a to the fourth minus 5a to the first. Is it a difference or sum? Yes. Is it perfect cubes? No. But, yes, common factor. What could I take out of each? 5 and an a. Good job. You are all smart. So GCF this time is 5a. So when we take 5a out, what's left over? A cubed minus 1. Good. So what pattern is this? Is it a sum or difference? It is a difference, and is it a difference of square or a difference of cubes? Good. All right. What is technically my a value? A is a this time. That's nice. And what is technically my b value? What is the cube root of 1? Just 1. That's the piece I wasn't sure if you would get by yourself, because it's almost too easy. The cube root of 1 is just 1. The 20th root of 1 is 1. Okay? We like the number 1. All right, so this is where I'm going to stop, and I want you to finish out the formula. So I helped you start it. You're going to finish putting it in its formula state. All right, what's going to go in my first parenthesis? A minus 1. Good. My a value was 1. My a value is a. Oh my gosh, I can't talk. My sign stays the same, so it's minus, and my b value was 1. So far, so good? Yeah. All right. Now, it's always a squared, ab, b squared. So what is a squared going to be? A squared, ab, b. What is a squared going to be? A squared. Okay? The signs in between. The next one is going to be opposite because of SOAP. So opposite sign means it's going to be positive. Now I need to multiply these two together. That gives me what?
1a.
Gives me 1a. Do I have to write 1a?
No.
No, I could just say a, but I like things to make sense, so I'm going to put 1a. That's just a me thing. And then always positive. What is my b squared?
1.
1. All right, and then this is where we are done. Yes? Oh, yes, we do. Look at that. She caught me. Yep, GCF. GCF. In first period, you're always smarter than the teacher. Yes, there is a GCF.
I get what you're afraid of when you're recording.
I know, I told you. I think I'm nervous. Haven't had the coffee yet. Ladies.
You drinking the coffee right now?
I am. Okay. Would you like to do the next one by yourself?
No.
Do you want me to start it? And then, okay. Okay, let me start it. Okay, number 5. We have 3x to the 4th y minus 81xy. Okay? There is a difference, which is awesome, but do we have squares or cubes? No, we don't have a difference of squares or a difference of cubes right now. Okay? But someone said it, there is a GCF. What could I take away from each piece? I could take away a 3 an x, and a y from each of these pieces. 3xy, 3xy. Alright, so what is 3? What is 3 divided by 3? 1. Okay, that one's gone. What's x fourth divided by x?
X to the third.
X cubed, good. And what's y divided by y?
1.
Just 1, right? So there was nothing left there. Okay, keep my sign. Next piece, what is 81 divided by 3?
27.
Okay. What is x divided by x?
1.
And what's y divided by y?
1.
1. So we have 3xy times x cubed minus 27. Okay. So now, do we have a difference of squares or cubes?
Yes.
Which one?
Cube.
A difference of cubes. Yep, we have a difference of cubes. So I'm going to just write the formula up here to help me. So I'm going to have a minus b, right? Then we're going to have a squared. Good. AB, then b squared. Okay? Helps to know what's my a and what's my b, right? My a is technically what this time? Is the x. Good. Because it's the cube root of x cubed is x. And then my b this time, so what is, what is the cube root of 27?
3.
It is 3. So a is x, b is 3. Can I stop and you set it up?
Okay.
And we're not going to forget the GCF this time, me either. So don't forget that 3xy is still out here. Then plug everything else in. Okay, so what's in my first set of parentheses? X minus 3. Good.
Yeah.
All right, how do I set up my next parenthesis?
X squared.
Good. X squared
3x
plus 3x.
plus 27.
Okay, careful.
Oh, it's a square, so it's
What is 3 squared?
9.
It is 9.
So I got one thing wrong.
It is 9. All right? Remember, 3 squared is 3 times 3. Excuse me. Okay. So I did see better things this time. Questions for me? All right, I would like for you to try the last one. All on you. Okay? We can talk about it first. Do you have to do anything to set it up? Do you have to take anything out?
Yes. Oh, you already take 8 out.
Okay, so I've given you a heads up. This has a GCF. Okay, so I'm going to stop. You're going to try doing this whole thing. Okay? All right, struggling is a good thing. And it is okay if you are not perfect right now. It is okay. All right, that is the point of learning. That is the point of practicing on your homework, okay? It is okay to not be perfect. Some people, I see some of your faces, you're getting frustrated, okay? It's okay. Your GCF is going to be 8AB. You can divide an 8, an A, and a B out of both pieces. When you do that, you are left with a B cubed plus 8A cubed inside, okay? To get your A and your B out of that, take the cube root of both pieces, okay? What is the cube root of B cubed? Just B, right? What is the cube root of 8 A cubed? Well, the cube root of 8 is 2. The cube root of A cubed is A. All right, so the pieces we are working with. So we have my GCF out front, which is 8AB. All right, then we're going to have B plus 2A. That's how it should start. That is how it should start. I know they use the variables A and B within it, which could also be confusing. Think of A as your first piece, your B as your second piece. Okay? I will try in the future to not use A's and B's, because that does get a little mixed up. And there's harder things for you to figure out besides getting variables mixed up. Okay? All right, now, next is my a squared, which is technically b squared. Okay, my next sign is opposite. The middle piece is a times b, so I need b times 2a. What does that give me?
2AB.
2ab. Yes, I got this one. I don't understand why that keeps bouncing. All right, now we have b squared. My b is technically 2a, right? So when I square 2a, I square both pieces. So 2 squared is,
4.
and a squared is
8 squared.
a squared. So it's 4a squared, like that. Some of you did get it. Some of you were real close. Some of you kind of gave up along the way. This one was hard. Yes, ma'am. Nope, we're going to leave it alone.
Okay, great.
Yep, we're going to leave this one alone.
That's the same thing.
Yep, this one is done. This one's done. I know, that was a lot. That was a lot. Okay. Looking at your homework. Okay. So yesterday was that other half of the worksheet is just your differences squares. So it's the first couple problems we did today, where it's a plus b, a minus b. All right. The worksheet you got today is all of your cubes. Okay. I would write your formulas at the top of that paper. The paper you got today, I would write down. I would have this the top of my paper. All right, and I would have this at the top of my paper. Plus AB plus B squared. That's when I have the difference of cubes. Okay, so the worksheet you got today, that 1 through 12 big one, okay, make sure that's at the top.
We finished it.
Make sure that's at the top. No. Difference of squares. So when you have two perfect squares like this, that's a plus b and then a minus b, like that. So this is from the, you'll use that for the worksheet you got yesterday, that half sheet. The top two you'll use for the worksheet you got today. And don't forget, if you have a GCF, it always goes out front. Okay? Maybe? Okay. So we do have, what, 5-ish minutes or so? So just work with what you can. Remember, you will give this to me on Tuesday. Okay?